Okay, so using switch is not the only way to do it. In fact, you can also do it using pointers to functions. So here we have the same set of functions: add, subtract, multiply, and divide. But if you look inside the main function, what we have here is actually an array of pointers to functions. So func here is an array of pointers to functions. So it can hold addresses of functions provided that that function doesn't have any parameters. That's why you have an empty bracket here, or I mean empty parenthesis, and it returns a void. Okay, so we can initialize our array here with our value list, which contains the name of the functions: add, subtract, multiply, and divide. So meaning to say, the address of add will be stored in the first index, and the address of subtract will be stored in the second index, multiply in the third index, and divide in the fourth index. Okay, but supposing that add doesn't return void, or if it returns an integer, then you cannot put add inside our value list. Okay, so you can only put functions here that returns void and doesn't have any parameters included. Okay, so again, func here is an array of pointers to functions. So we have the same prompt and the same menu, but look at our code. So it now becomes shorter because you cannot see anymore a switch statement, but what we have here is our function call, which is calling the function through our array func, which is an array of pointers to func. Okay, so for instance, if the input of the user is 2, then the value of n is 2. Then we need to subtract it by 1 since array starts its index at 0. So since the value of n here is 2 minus 1, so we have index 1. So meaning to say, the address located in index 1 will be the reference, which actually points to the function subtract. And the flow of control will be transferred to the function subtract, and it will display this function. Okay? So not only will it make your program shorter, but it's actually very faster compared to using a switch, because you do not need to compare each case statement anymore until it finds its match. So here it's very automatic. So whatever the value of n is, just subtract it by 1 to get the correct index, and the address located in that index will be the reference to get the correct operation that the user chooses. Okay? So let's go back to dynamic memory allocation. So once compiled, all C programs organize the computer's memory into 4 regions, which hold the program code, the global data, the stack, and the heap. So all the codes in your program, including the functions that you have created, will be stored in the program code. And all the permanent data, which includes global variables, will be stored in global data. And the temporary variables like the local variables and the function parameters are stored in the stack. So the heap, on the other hand, is a free memory region that lies between the program's permanent storage and the stack. And we use the heap to satisfy dynamic allocation requests. Meaning, you cannot just use the heap anytime you want. You need to make a request so that the memory can be allocated from the heap. So there are advantages to using the heap. So first, same memory can be used for several different things in the course of a program's execution. So meaning to say, so if you allocate your memory from the heap and you already finished using that memory, you can return it back to the heap and use that same memory allocation again. Okay? And secondly, it allows the creation of linked list. So you will learn about linked list during your data structures course. Okay, so what are the functions that we use to request memory from the heap? So one is using malloc. So it's a function for runtime storage allocation. Okay, so if successful, it returns a void pointer to the allocated storage. Otherwise, if the request cannot be satisfied, meaning to say you do not have enough memory anymore in your heap, then it will return null. So the general form or the syntax for using malloc is this. So you need a pointer variable, okay? Then your malloc is here. Then we use the size of operator, which will return the memory in bytes of the data type that you have requested to be allocated from the heap. And the data type here, which is a pointer. Okay, so for example, so if you want to allocate an integer from the heap, so we declare an integer pointer. So ptr here is a pointer to int. Okay, then this is how we do it following the syntax. So we use size of int. So meaning to say, if the machine uses 2 bytes of memory for integer, then it will allocate 2 bytes of memory from the heap, and the address of that memory will be stored in ptr. Okay, so we have to cast it. We call this cast because the address that the pointer or malloc returns is void. So to make it compatible with the data type of the memory that will allocate from the heap, so we need to use casting. Okay, so we cast it as a pointer to int. Okay, so here is an example that allocates runtime storage depending on the user's response to a prompt. So prior to running this code here, we do not know yet what data type will be allocated, if it's memory for char or memory for an integer. So it is user dependent. So the only way you would know that is when you run this program and the user will make a choice. Okay, so here we declare variables pointer to char, just let, and response, which will hold the response of the user, and a pointer to an integer, which is ptr. Then you have a prompt here saying enter C for character if you want to allocate a character, which means 1 byte of memory only from the heap, or I for integer, which means 2 bytes of memory. Okay, then if the user will press C or I, it will be stored in the variable resp or response, and using the if statement here, it will compare if the value stored in the variable resp is equal to C, and if it's true, then a character or 1 byte of memory will be the one that will be allocated from the heap, and the pointer or the address to that memory from the heap will be stored in let, and using scanf we can read an input and store it into that memory cell. Okay, otherwise if the response is I, then we will be using the pointer variable num, and 2 bytes of memory will be allocated from the heap, and again using scanf it will read an input from the keyboard and store that input to the allocated memory from the heap.